Hello everyone, my name is Lixue Zhang. This is my paper presentation for course CS 6263. The title of the paper is A Large-Scale Empirical Analysis of Chinese Web Passwords. This paper states the differences between Chinese passwords and English passwords, including the details in password composition. Then it gives the methods of the guessing passwords and improvement. Today I will talk the basic introduction, the regional differences on passwords, crossing region guessing, and conclusion and future work. This paper mainly has three parts. The first one is the characteristic of Chinese passwords, which includes the most popular passwords, structures, and strengths of them. The second part is the patterns used in Chinese passwords. And at last, it tries to guess the Chinese passwords using the above analysis. The introduction states the basic understanding of Chinese and English passwords. The author leverages leaked available passwords from Chinese website and English website listed here. Then it gives security strengths of passwords and methods to improve password guessing, including analysis tools and guessing indicators, preference of the two groups of users, and improved PCFG password guessing method by adding pinyin. Finally, we summarized the findings and main contributions, including different character sets, patterns of languages and dates, and improvement of the efficiency of password guessing. When logging into internet, you have to register some accounts with passwords. You must have your unique type of passwords. Apparently, users from different regions prefer different types of passwords. Some literatures imply that Chinese passwords may be hard to guess. So here, this paper addresses two problems. Does Chinese choose better passwords, and how can we guess them? This paper studies Chinese passwords because Chinese netizens are the biggest internet user group. This is the dataset setup. According to official reports of China Internet Development from CNNIC, there are over 600 million netizens in China. In addition, the security of Chinese web services is worrisome. The 5 Chinese websites CSDN, Tianya, DDNew, 7K7K, and Y178.com have leaked their plaintext passwords, which are publicly available in the past few years. With the leaked passwords from Roku and Yahoo, this paper leverages over 100 million plain text passwords to analyze the features of Chinese passwords. Let's see the most popular passwords first. According to this paper, we can see that passwords 126 and 129 are the most popular passwords, both in Chinese and English data sites. Another point is that all the popular passwords in Chinese data sites are digits only. Actually, more than half of the passwords are digits only in Chinese data sites. And in this figure, it lists every printable character in the descending order according to their presence in Chinese passwords. The first 10 characters are all digits, and the presence of all digits in Chinese data sites are more than those in English data sites. Then, English type passwords contain more letters and symbols. For the compositions and structures of passwords, why do Chinese people prefer digits? There are only Chinese characters have only 400 kinds of pronunciation elements, ignoring the tongues. So, Some pronunciation of some digits are similar to those of Chinese characters. Thus, the pronunciation of a sequence of digits may sound like a sentence. For example, the pronunciation of 520 sounds like I love you in Chinese. English word often appears in the passwords. The reason is maybe that English words can be typed directly in the keyboard. However, Chinese characters cannot. What can be directly typed in the keyboard is the pinyin of Chinese characters. Pinyin is the way to represent the pronunciation of Chinese characters. For both password groups, a good portion of passwords contain both letters and digits, and no obvious differences seem to exist between these websites. Sometimes users prefer to create their passwords according to the keyboard patterns. It is divided as the same row pattern, zigzag pattern, and snake pattern. Algorithm to identify keyboard patterns is used to classify passwords by assigning coordinates to each character on the keyboard, like X and Y. Although there are many dialects in China, Pinyin is the only way to show their words. In the letter-only passwords, about 30% to 60% Chinese passwords are the combination of pinyins. And in the mixed passwords, which means passwords contain letters and other types of characters, there are about 20% of passwords containing pinyin. One interesting factor is that there is always one thing in the passwords, that is love. The first in the top Chinese pinyin means I love you in English, and Chinese surnames are also very popular. The second, the third, and the fifth top Chinese pinyins are Chinese surnames. Dates are also popular in Chinese passwords since they can be typed as digits. This paper extracts the sequence of exact 6 digits and 8 digits in order to analyze the two typical types of dates. In this table, we can see most users put the year at beginning, and in Roku and Yahoo, the users usually put the year at the end. And shown in the last table, for all Chinese and English websites except Dudumu, most dates observed in our analysis are digit-only passwords. For Dudumu, the passwords that contain dates are more likely to contain both digits and letters than digits only. This could be because Dudumu is it's a commercial website, and its users tend to choose a password with stronger strings. For the 6-digit dates, the situation is similar. This coincides with the user's habits of different regions. Another observation is that dates are often put at the end of the passwords. About 70% dates are put at the end, no matter in which dataset. Since there are so many digits in Chinese datasets, are they easier to guess? Let's measure the strings to see the result. Recently, the resistance to guessing is mostly used to measure the password strings. Alpha work factor is one of the measurements. Alpha work factor is the expected numbers of guesses needs to succeed with probability alpha. As shown in this table, we briefly introduce this matrix. H infinite is defined as worst-case security metric for human choosing passwords. G is defined as a guesswork representing the expected number of sequential guesses to find a password of an account if an attacker proceeds by trying passwords in descending order of the password probability. Mu alpha is called marginal guesswork or alpha work factor, which measures the expected number of guesses used to succeed with probability alpha. Marginal success rate or beta success rate, lambda beta, represents the probability that an attacker can correctly guess the password of an account given beta guesses. G alpha, the alpha guesswork, reflects the expected numbers of guesses per account to achieve a success rate alpha. There is one assumption that the attacker knows the distribution of the dataset. For example, the dataset has 4 passwords. Each password occupies a certain proportion. And if alpha is 0.4, which means the attacker wants to guess 40% of the accounts, he only needs to guess once. So alpha work factor here is 1. And if alpha is 0.9, the attacker needs to guess the first 3 passwords, so alpha work factor is 3. This section assumes that attacker knows the exact distribution of the target password set and calculates the password strength. This is called intra-set guessing. In the table, the beta success rate lambda 5 lambda 10 of Roku and Yahoo are much lower than those of Chinese websites. This phenomenon shows that Chinese websites have a lot of repeated passwords, but the G0.25 and G0.5 are similar, less than 3, between Chinese and English websites except 178.com. So, it may be easier to guess a small proportion of Chinese passwords, but for a majority of Chinese passwords, guessing them becomes as hard as guessing English ones. In the real cases, alpha work factor may be a very large number, so we can guess it into the unit of bits. This figure shows the curves of alpha work factors and different alpha values of the 7 websites. The 2 dotted lines belong to Roku and Yahoo. We can see that at the very beginning, the alpha work factors of them are bigger than others in Chinese datasets. But after 0.25, they are similar. Doodle and 178.com is an exception. 178.com is a little geek website, and Doodle is a commercial website, so they may perform difference with others. For this section, it shows how well an attacker can guess passwords from a website when he only owns a password set of another website, which is called as a cross-site password guessing. This represents the situation between an attacker wants to correct passwords from a website whose passwords have never been leaked. The matrix is modified from intra-website password guessing to evaluate a cross-site password guessing, as alpha work factors and beta success rates to evaluate the resistance to cross-site guessing. The result of alpha work factors and beta success rates of cross-site guessings are shown in the picture, where we can conclude that cross-site guessing is much harder than intra-site guessing. A lower beta success rate means that the probability of correct guesses, even beta guesses, are lower. In cases of using the information of Chinese password to guess the ROCU passwords, the beta success rates lambda 5 to lambda 10 are lower than the intra-site guessing ones. In case of using the information of ROCU passwords to guess Chinese passwords, the beta success rates lambda 5 to lambda 10 are also lower than the corresponding intra-site guessing listed in the table. A higher alpha work factor means that it takes a larger number of guesses to hit the right passwords. Compared with intra-site guessing, which is shown in picture, for the same alpha value, the alpha work factors of the cross-site guessing shown in the picture is larger, so cross-site guessing is harder. Now we can guess the Chinese passwords according to the analysis. The guessing method is based on PCFG, a probabilistic context-free grammar. This grammar describes the structures of passwords using a set of rules, and it's a dictionary guessing indeed. There is an example. Since the rules are generated from the training set, for example, the passwords from the training set has two structures. 30% of the passwords have 5 letters, 3 digits, represented by L5D3, and 30% of the passwords have 2 symbols, 3 letters, 3 digits, represented by S2L3D3. The 3 digits may be 1 to 3 with the probability 60%, or 3 to 1 with the probability 40%. The 2 symbols may be 2 hash signs or 2 stars with equal probability. And we will fill the better using the dictionaries, the dictionary guess. So every password we generate has a probability. We can guess the passwords with the probability. Training set and dictionaries are the 2 things we need. This paper selected 4 training sets from 1 Chinese dataset Dudu and 1 English dataset ROCU. Passwords in ROCU TS and Dudu TS are 2 million passwords randomly selected from ROCU and Dudu respectively. And ROCU TS are selected from ROCU, but we made it 50% digit only passwords, 10% letter only passwords. These proportions are close to the Chinese ones. The ROCU Dudu TS are selected from ROCU and Dudu at the same time. There are 2 dictionaries, the English dictionary and Chinese dictionary, which are written as edict and cdict. The edict is the combination of dict 0294 and English Global, which are 2 popular dictionaries. And if we add 20,000 most popular pinyin into the edict, we get the cdict. The C digit is used to represent the influence of pinyin. This paper also adds the 20 most popular 6-digit and 8-digit dates into rows to represent the influence of dates. After 10 billion guesses, this figure shows the result. We divided the figure into 4 parts. Each one training set is 1 part. The first column in each part means the guessing using the English dictionary. If using Chinese dictionary, we get the second column with the good improvement. If we add the dates, we get the third column. We didn't add the dates as the last 2 training sets because they already contain many Chinese dates. Finally, if we use Chinese dictionary and add the rows of dates, we will get a considerable improvement for the MWTS. We increase the guessing efficiency by 34%. So, Chinese passwords have over 50% digit-only passwords, and they contain many pins. This paper increased the guessing efficiency by 34%. In the further studies, we can use the pinyin and dates to improve the guessing efficiency for them. Thank you very much